In this video, we're going to talk about radians. We're going to go into a detailed explanation of what radians are, then we're going to talk about coterminal angles, and then we're going to finish by talking about the complement and the supplement angles. So the first thing that we need to talk about is the distances on the unit circle. So if you remember, the unit circle is a circle around the origin with radius 1. So looking at my first picture here is my origin, the point 0, 0, and I have a radius of 1. So if you recall, the circumference of a circle equals 2 pi r, where r is the radius of a circle. When we are considering the unit circle, our radius is 1, so our circumference is 2 pi times 1, which then simplifies to just 2 pi. So now if I start at 0 degrees and I travel all the way around my circle and make one full complete rotation, I have traveled a distance of 2 pi. If I travel, say, from 0 degrees to 180 degrees, meaning I cut that distance I have traveled in half, then I'm going to have 2 pi divided by 2, since I'm cutting it in half, and I'm going to be left with just pi. So if I travel from 0 degrees to 180 degrees, I have traveled a distance of pi. So on this screen, there's a bunch of different examples of the different distances within the unit circle, considering what we've just learned, that if I go all the way around the circle, I have traveled a distance of 2 pi. If I go halfway, I have traveled a distance of pi. So if I've traveled from 0 degrees to 90 degrees, that means I've traveled a quarter of that circle. So I would have 1/4 times 2 pi, which simplifies to 2 over pi. So if I travel a quarter of the way around my unit circle, I have traveled a distance of pi over 2. So we can use this concept and we can continuously break down different distances we have traveled along our unit circle. So for this next example, instead of traveling a quarter, I have actually split the quarter in half, which means from 0 degrees to this point, I have traveled 1/8 distance around the entire unit circle 2 pi, which gives me 2 pi divided by 8, which then simplifies to pi over 4. So for this next example, instead of traveling just a quarter of the unit circle, I went pi over 4 beyond a quarter. So in this case, we already said that if I go a quarter of the unit circle, I have traveled a distance of pi over 2. In the third example, we said that if I travel 1/8 of the unit circle, I've traveled pi over 4. So if I start here, I'm actually going to travel 3/8 around my unit circle. So I would then have pi over 2 plus pi over 4, get a common denominator, and I would have 3 pi over 4. So when I have traveled 3/8 distance around my unit circle, I have traveled a distance of 3 pi over 4. So again, like I said, we can keep basically breaking the unit circle into little sections and keep adding, okay, do I want to go halfway around my circle? Do I want to go a quarter of the way, 1/8 of a way, 3/8 of the way? And we can represent that by radians. So a radian measure is what we've been talking about. So a degree measure is a common unit of angle measure, and that's what we've been using all along our degree measures. However, another form of an angle measure is called a radian. And 1 radian is approximately 57.3 degrees. So as you can see in this first picture, we traveled a distance of 1 radian, which is approximately 57.3 degrees. In the second picture, I have traveled 2 radians to put me in the second quadrant. And again, since 1 radian equals 57.3 degrees, traveling a distance of 3 radians still puts me in the second quadrant because that would give me 3 times 57.3 degrees. 3 times 57.3 degrees gives me 171.9. 171.9 degrees. So you can definitely tell that's less than 180 degrees. So as you can see, 3 radians equals approximately 171.9 degrees. So I would definitely be in quadrant 2. 6 radians, well, 6 times 57.3 degrees gives me 343.8, approximately 343.8 degrees. So as you can see, each radian is going to, again, kind of move me along the unit circle, and it's just another form of how we can measure an angle. So again, we've kind of been leading up to this point throughout this entire video. This is the unit circle broken down into its different radian measures. So as you can see, here is that eighth that we were talking about earlier, pi over 4. Here's the quarter measure we were talking about earlier, pi over 2. Traveling half of the distance around my unit circle gives me pi. To get to this number, we would take pi and then, of course, add 1/4 to it. Then again, we could say that this is 75% of my unit circle. So since this is 75% around my unit circle, we could simply say, well, that's 3/4 times 2 pi. And that's going to give me 6 pi over 4, which simplifies to the 3 pi over 2 that you're seeing right here. So we basically can just keep breaking this down into little pieces of pi slivers. So this 1/6 here, you can do one of two ways. So this tells me I'm in radians. So to convert this back to degrees, I would simply need to use pi radians times 180 degrees. My pi radians would cancel out, and I would have 180 degrees divided by 6. And 180 degrees divided by 6 is 30 degrees. So to get from this 0 degrees up to pi over 6, I've traveled a distance of 30 degrees, or I have traveled a distance of pi over 6 degrees. So to get to this next value, pi over 4, we said that that was an eighth of a way around the unit circle. So we would have 360 degrees divided by 8 gives me 45 degrees. So the second value means I have traveled 45 degrees, or I have traveled pi over 4 degrees. In order to get to pi over 3 degrees, this time I'm going to use that conversion. So I have 180 degrees divided by pi radians. My pi radians cancel out, and I'm left with 180 divided by 3 gives me 60 degrees. So as you can see that we're kind of increasing by a certain amount each time. All right, so next we're going to talk about coterminal angles. If you remember, as I said in the angles video, to find a coterminal angle, we add or subtract multiples of 360 degrees. But since we're in radians, instead of adding or subtracting 360 degrees, we're going to add or subtract 2 pi radians. So it's asking us to find a positive angle and a negative angle that are coterminal with the given angle. So we're going to have negative 2 pi over 3, and then we're going to add multiples, add or subtract multiples of 2 pi. So here I need to get a common denominator. So I'm going to multiply top and bottom by 3. That's going to get me negative 2 pi over 3 plus 6 pi over 3, which simplifies to 4 pi over 3. So this is a positive angle that is coterminal to negative 2 pi over 3. To find a negative angle, we can just simply take our angle, negative 2 pi over 3, and subtract 2 pi. Again, multiplying both numerator and denominator by 3, I'm going to get negative 2 pi over 3 minus 6 pi over 3, and that's going to leave me with negative 8 pi over 3. So this is a negative angle that is coterminal to negative 2 pi over 3. Looking at this next example, we have pi over 4. Again, to find the positive coterminal angle, we're going to add 2 pi. In this case, I need to multiply both the denominator and the numerator by 4 in order to get the common denominator in order to be able to add my two fractions. So I'm going to get pi over 4 plus 8 pi over 4 equals 9 pi over 4. And then to find my negative, I'm going to subtract 2 pi, which as we said a minute ago was just 8 pi over 4. That's the same thing as 2 pi after multiplying both your numerator and denominator by 4. And that's going to leave me with negative 7 pi over 4. And that's my negative angle that's coterminal to pi over 4. All right, the last thing we're going to talk about is the complements and supplements of angles. So if you remember again from the angles video where we talked about all of this stuff in terms of degrees, so if we have the complements of our angles sum to 90 degrees, that's the same thing as saying pi over 2 radians. And our supplementary angles sum to 180 degrees, which is the same thing as pi radians. So if we need to find the complement and supplement of the given angles, here we have pi over 6. So remember these two angles need to sum to equal pi over 2 or pi. So we have x plus pi over 6 needs to equal pi over 2, and that's going to be the complementary angle. So solving for x, I get x equals pi over 2 minus pi over 6. Need to again get a common denominator before I can subtract my fractions. So I'm going to multiply both numerator and denominator by 3, and that gives me 3 pi over 6 minus pi over 6, and I get x equals 2 pi over 6, which again simplifies to pi over. So pi over 3 is the complement of pi over 6. Pi over 6 plus pi over 3 gives me pi over 2. So next we need to find the supplementary. Again, x plus pi over 6. Supplementary needs to add together to equal pi. Solving for x, I'm going to get x equals pi minus pi over 6. Multiplying both numerator and denominator by 6 in order to get a common denominator, I'm going to get x equals 5 pi over 6. All right, in this last example, we have 5 pi over 12. Again, we need to find the complement and the supplement of this angle. So we're going to start with the complement, x plus 5 pi over 12. These two angles need to sum to equal pi over 2. Solving for x, x equals pi over 2 minus 5 pi over 12. All right, multiplying both numerator and denominator by 6. I'm going to get x equals pi over 12. So pi over 12 and 5 pi over 12 are complementary. Next, we're going to find the supplementary angle. So we have x plus 5 pi over 12 needs to equal pi. Solving for x, I get pi minus 5 pi over 12. Again, getting that common denominator, I'm going to multiply both numerator and denominator by 12. And that's going to get me x equals 7 pi over 12. So that's really all you need to know about radians, coterminal angles, and how to find the complement and supplement angles when you're in radians instead of degrees.